Welcome back to the workshop. We want to continue taking a look at the first section of the appendix of our text on logic and proofs. So we're taking a look at statements and connectives. Here, we want to begin taking a look at connectives. So what are connectives? Well, as the name suggests, they connect things. And as the title of the section would suggest, they're connecting statements. So let's take a look at connectives, which connect statements. So connectives will join two statements by saying that we want particular conditions. We want two statements to be combined, and the combining of them we want to be true in some situations and not other situations. Now, most of these connectives we're actually pretty familiar with, at least the first three, let's say. So there are several connectives that we'll take a look at. The last one is actually technically a combination of the previous one. And technically, again, this one is actually technically a combination of the preceding three. So in its most basic sense, we're actually just looking at three, and then we tack on the last two to say to ourselves, all right, we look at them a little bit differently, because we're familiar with these sorts of phrases. So there are five that we'll take a look at. The first connective is not. The symbol for it is I believe this is called a tilde, and then it's called negation. So the negation of a statement is not the statement. So if the statement is today is Friday, then the negation of it would be today is not Friday. Okay. The and connective to connect two statements, this statement and another one, is given this symbol. So it's like an A, but it doesn't have a piece across. And it is called conjunction. There's the connection of or. So this statement or another statement is called disjunction. And it's represented by a V. So we connect them with a V. And then we have if something, oh, and actually that's a typo, my apologies. If then, there we go. So if something, then if one statement, then another statement. And then finally we have if and only if. Statement, if and only if, other statement. So we'll take a look at these. Right, these are not the definitions. These are just, hey, these are what they are. And we're going to take a look at the definitions of them as we go along. So first, let's take a look at the connective negation, okay, or not. So what does it mean to negate a statement? Well, it's just giving us the opposite sort of situation. So what we want to do is we want to give the negation of these statements. So what does this look like? So we can think of it as it's denying the statement. So if S is that April 8th, 2021 is a Thursday, then the denial of that would be that it's not a Thursday. You are crazy. No, I'm not. I'm denying it. I'm negating it, okay? So not S would be that April 8th, 2021 is not a Thursday. That is negation. The negation of the statement is using not. Okay. What about T? 12 plus 5 is equal to 17. We notice that this, in fact, is a true statement, much like S was a true statement. April 8th, I do believe, was a Thursday. And 12 plus 5 is, in fact, 17. So while S is true, the negation of it is false. And then same thing here, right? The negation of T would be that 12 plus 5 is not equal to. Now, when you're typing, exclamation point equals is to say not equal to. 12 plus 5 is not 17. Of course, we know that is false. 12 plus 5 is 17. We could also write it as not T 12 plus 5 is not equal to 17, using our usual notation. When you're writing by hand, I, of course, would encourage you to use that notation. All right, so Keanu Reeves is not Mr. Anderson. What is the negation of that? Well, this already has a not in it. So would it be Keanu Reeves is not Mr. Anderson? Yes, I suppose it would be, but not, right? Much like the English language works, when you have a double negative, you end up with the canceling. So Keanu Reeves is Mr. Anderson. So the negation of R in this case, which already has a not in it, will give us that Keanu Reeves is Mr. Anderson. And while I don't think that he would deny that, he might correct you and tell you that his name is Neo. All right, so these last two are a little bit more interesting because they have what are called qualifiers. So this statement contains a qualifier. And what's that qualifier? Well, that qualifier is the word sum. And to know how to handle this, we have to kind of get an idea of how to negate this, because the sum makes a really big difference. So if the statement is that some smartphones charge wirelessly, and we want to negate it, we want to give the opposite situation, I can't just say some smartphones don't charge wirelessly, or some smartphones do not charge wirelessly. That's not the correct negation. If I want to negate it, what I actually need to do is I need to say that no smartphone charges wirelessly. So the negation of this would actually be, the negation of P would actually be that no smartphone charges wirelessly. Wirelessly. I think that's the correct spelling. Yeah, whatever. Anyway, so why do we end up with this no smartphones charge wirelessly? Well, you want to think of it as true and false. If it's true that some smartphones charge wirelessly, then it is also true that some smartphones do not charge wirelessly, or has the potential to be. So I want to change this from a true statement to a false statement. So some smartphones charge wirelessly. That is in fact true. I used to have one. I downgraded. Mine doesn't anymore. But the negation of this would have to make it a false statement. So if we know that some do, to make it false, we would have to say that all do not charge wirelessly. Okay, so the negation of some is all, right? The idea of some smartphones charge wirelessly, we can say maybe a little bit more exactly by saying there exists a phone that charges wirelessly. And the negation of that would be that all smartphones do not charge wirelessly. You'll find that most texts phrased it in this way, the idea of do not charge wirelessly. So what I'm trying to say there is that if we have there exists a smartphone, well, here, let's see here, there exists a smartphone that charges wirelessly. The negation of that would actually be for all smartphones do not charge wirelessly. So there exists becomes for all, and P, whatever the statement is that follows all or some, becomes not that. So some smartphones charge wirelessly, all smartphones do not charge wirelessly. But this isn't necessarily the language that you'll see in the particular text we're using. Their language looks more similar to this presentation here. The statement is some do, the negation is none do. Okay, That is, all of them do not. All right, so we said that there are two qualifiers, and our next statement actually has that other qualifier, all. So here, all undergraduate courses are running online this semester. And I believe that is false, right? We are primarily online right now, but I also have other courses that I'm teaching that are not strictly online. So I would say that this is false. So anyway, we want to take a look at the negation of it. But if we have, if we want to say that all undergraduate courses are online, and we want to give the negation of that, we would simply say, hey, we can actually find one that is not online. So all undergraduate courses running online becomes, so the negation of Q would be, there is an undergraduate course this semester that is not online. Excellent. So right there, when I say there is, I mean there exists. There exists an undergraduate course this semester that is not online. So much like the negation of there exists became all, similarly, the negation of there exists something becomes for all that something is not that something. Okay. So this is kind of what's going on there. This is some really nice mathematical notation. Again, that notation isn't used in this particular text, so these give the right idea for what we're looking for. But we want to understand that the qualifiers have to be dealt with appropriately. If this statement were simply smartphones charge wirelessly, the negation would be smartphones do not charge wirelessly. Okay, and if I didn't want to have a qualifier here, it would be undergraduate courses are running online this semester, and the negation would be undergraduate courses are not running online this semester. So by adding that qualifier, I'm just swapping the qualifier before I negate that statement. So some smartphones charge wirelessly, all smartphones do not charge wirelessly. All undergraduate courses are running online. Some undergraduate courses are not running online. And that's the basic idea. So there's one more thing I want to add to our discussion here, and that's a little bit about truth tables. So let's take a look very briefly at truth tables. So truth tables give the possible combinations of truth values for a statement. Now, in the case of the statements that we're looking at here, right, if we choose one particular statement, P, the only possible values for P are that it's true or false, right? We're taking a look at the truth values here. So for a statement P, it can either be true or it can be false. And when I consider not P, then when P is true, not P would be false. And when P is false, not P would be true. Okay, so the negation changes the statement. I am, let's see, what am I? I am a professor. It is true. I am not a professor. That is false. Okay, by adding the not, we change the truth value. Excellent. We'll continue taking a look at connectives in our next video. So I'll see you guys back in the workshop very shortly.